I hope your day is going well. My name is Nina, and I'm a developer at Braintree. I'm particularly passionate about code quality and developer productivity. So you're going to walk out of this room today knowing how to successfully grow a code review culture. Before I start, I know there might be some designers in this room. I wanted to warn you that I am not one of you. So if my slides make you cry, please don't throw tomatoes at me until the end of my talk. What are we going to learn today? Firstly, who's the target audience here? Well, I want to talk to both team leaders and developers. We're going to talk about why we review, what the benefits are. I'm going to tell you a little bit more about my personal process. We're going to learn how to grow and nurture a code review culture. Next, I'm going to give you some specific examples about how to be both an effective reviewer, but also an effective submitter. Lastly, I'm going to share how we're going to use these tools to build a stronger team. But remember, not one size fits all. I'm here offering suggestions to you. It's up to you to adjust them to your own work situation. What are the factors? Team size, first off. Taking the time to review is going to affect a team of 2 people a lot harder than a team of 10. It depends on your product type. So if you're working for an agency, you might have tighter deadlines and more incentive to push code out the door versus if you're working in-house. And we need to know what your defect tolerance is. What is a defect tolerance? It's the rate of failure that's acceptable in your software. So if you're dealing with money or medical equipment, you should have a much lower defect tolerance than if you're working on something like a web app or a video game. But we need to answer the question first, why should we code review? Why do we bother? Because on the surface, code reviews can appear really frustrating. I mean, just look at this developer. She's so frustrated at the idea of reviewing code that she's just eating her laptop. You don't want to be her, right? So what are some apparent code review frustrations? It can add a time demand. Like I said, that's especially noticeable if you're on a smaller team. It can add process, and we know that everybody hates process, right? If the review process can also bring up some hidden tensions between team members, and it can also flare up egos because some smart developers think that they don't need to be reviewed. Now, how do you get people to change the way that they work? Because inspiring change is always difficult. People get really comfortable in their routines. If you don't already review code, how do you go about introducing the concept? Well, first, you need to start by selling the benefits. In the short term, frustrations are inevitable. When you first start, you need to expect things to be pretty slow going. But in the long term, it'll make your life easier because, like with all things, the more practice you have, the better your velocity is going to be over time. I've been on a team that does reviews for about a year now, and it took me about 2 months until the process became sick in nature. The biggest benefit, review helps you find flaws in your design and bugs. These flaws can be found and fixed before your code is shipped. And multiple case studies from IBM, AT&T, Microsoft have shown that code review can lower the bug rate by about 80%, but it can also increase your productivity by up to 15%. So big impact here. The goal is to find bugs before your customers do. It's not to show off who's smarter. You want to save face. One way of doing that is reviews, they help us feel a shared sense of ownership. It reminds us that we're all in this together, and when I know that someone's looking at my code, it motivates me to write better code. That positive motivating pressure will result in an increase in code quality. Reviews also help us share knowledge throughout the team. You don't want one developer to be the only expert, and developers will gain familiarity with different parts of the code base by doing reviews. This decreases what's sometimes known as the buzz factor. What is the buzz factor? It's a measurement of how much specialized knowledge belongs to any one individual team member. If the buzz factor is too gruesome, you can think of it as the lottery factor instead. So who's heard something like, only Alice works on the authentication system, no one else understands how it works, and so we're not going to touch it? How do you measure the buzz factor? In your mind, go through each person on your team and ask yourself, can the project still go on if they stopped coming into the office tomorrow? So think about what happens when Alice wins the lottery. Code reviews also leave behind a paper trail. A review can add a wealth of knowledge about why a particular decision was made. A good code review tool will let you review those comments and the dialogue that was left before a merge and say, why was a particular decision made? So in summary, our code review benefits, they let us find bugs. We share ownership in the product. We share knowledge about our code. We reduce that all-important buzz factor, and we leave a paper trail behind. My current organization has a great review culture. It's not just anecdotes. I've worked as a developer for many years, and I used to think, maybe like some of you, that I knew it all. When I started at a company with a great review culture, I realized that there's always an opportunity to learn from others, and I started anticipating what a reviewer might point out before even getting to the review process. As a result, I've turned into a better programmer. I want to give you a little bit more insight into our process. So the tools that we use are GitHub Enterprise. Because of that, you might hear me use the terms review and pull request interchangeably. Be aware that many other tools exist. I used to have a lot of reservations about the pull request process, but lucky for us, GitHub just announced some new review tools in September of 2016. We now have formal reviews, so now instead of just commenting on a pull request, you can open up a real deal review. And that lets you set the status to either approved or changes requested on pull requests. We now have inline comments. Finally, threaded comments. When multiple comments used to be created for one line of code, it made them really hard to track. This was one of the most requested features of pull requests. And lastly, they introduced something called blocked merging. So administrators can now require reviews before merging into protected branches. When reviews are required for a protected branch, you have to have at least one approval and no outstanding requested changes before you can merge. Our workflow looks a little something like this. We make a feature branch. We hack, do the work, and then we open up a pull request in GitHub. Next, we assign a reviewer. Usually, we just ask in the Slack channel for somebody to volunteer. That person is going to complete the review. They say they're done. And then when the review is complete, we merge that feature branch back upstream. What are the advantages of a feature branch system? Firstly, our master branch is always stable, whereas development might not be. It lets us QA our changes in a staging environment that mimics production, and that's a huge improvement over testing changes on our local environment. But lastly, if we need to hotfix master, then we're not affected by any untested changes that might live in that development branch. So we talked about the culture, or we talked about the benefits. Now let's deep dive into how to grow the culture. First, it starts with a commitment to always review your code before merging. You need to present the facts. There have been so many case studies and research papers over the past few years that support reviews. I'm going to talk about a few of them later on. Suggest the idea, show the research, but don't force it because it takes time for new ideas to root. Code reviews need to be universal. It doesn't matter if you're a junior developer or if you're a senior developer. Everyone should be submitting and reviewing code. If only the senior developers do reviews, you've just created a huge bottleneck. I used to work with a developer in a Java shop who always insisted on formatting his Java code in C++ style instead of Java style. So he always put the opening bracket for a method on the next line instead of the same line, as is conventional in Java. As you can imagine, this made for some nightmare diffs and a lot of frustration amongst the team members who were maintaining his code. When I said something, when I spoke up, I was told, well, that's okay. He's Bob. He's allowed to do that because he's the most senior engineer. If you have that kind of environment, you're going to breed dissatisfaction through inequality. So for the review process to be really impactful, you need to break down those old barriers and status quos. Reviews need to be done by your peers and not by management, because the end goal isn't to get someone in trouble. If you find bugs during the code review process, they should never come up in a performance review. That's why we do code reviews in the first place. Reviews encourage consistent code. You need to remember a really important fact. The code that you write isn't yours. It actually belongs to your company. If that code needs to fit your company's style and your company's expectations, not your own. Reviews that encourage consistency make your code more robust. And code longevity is important because, let's be honest here, no one stays at a company forever. That's the truth. How do we enforce that consistency? The best way to do it is with a style guide. What's a style guide? It lets you distinguish personal taste from functionality. They should be agreed upon beforehand. Because a motto that I love is that great code bases were written by a team, but they look like they were written by an individual. I added some examples of great style guides at the end of my slides. Python has one called PEP8, and it's actually built into the language. It doesn't matter which one you choose, just pick one and stick with it. Consistent code is easier to maintain by a team. Maybe Bob wasn't wrong. Maybe C++ style formatting is in fact better, but the problem is he wasn't following convention. Consistent code is better. Reviews work best in a no-blame culture. We need to accept that failure is inevitable. But when the team reviews code, the team becomes responsible for code quality and not any individual. This needs management support. If you get in trouble for sharing your mistakes, you're just gonna brush them under the rug next time. A no-blame culture encourages you and your teammates to talk openly about what went wrong. As a bonus, I want to briefly touch on blameless postmortems, even though this usually happens after review. What is it? It's a meeting that happens pretty shortly after every incident. It lets you diagnose what the exact root cause was. During that meeting, you want to document all the events that led up to the issue. Even better, create a timeline. And now you can learn from it. You can identify how to prevent it in the future. Remember though, don't just talk about it. You need to actually assign and create tickets after your blameless postmortem. So for a blameless culture, don't point fingers, because who caused it is just not part of the conversation. The process works if punishment is off the table. You want developers to be honest about their mistakes. If you encourage sharing instead, everyone on the team can learn from mistakes. And a blameless postmortem is just a great way for managers to show support of this system. How do we know when a code review culture has taken root? When code reviews are part of the culture, developers are going to want to be reviewed. They're not just going to expect it. So, how do we grow a culture? We start by making a commitment that code reviews should be universal, and they should be performed by your peers. Style guides will encourage consistency. But it all starts with a no-blame culture. Now, how should we review code? There are 2 steps to learning the process. The first is, how can we be a great reviewer? The therapist asks his patient, why do you think you're so hostile in code reviews? And the developer laments, if only I had been more popular in high school. Code review should not look like an appointment with your therapist. Approach it objectively. Approach it without ego. You need to leave your emotions behind. You need to have empathy. Hostility at this step is especially not necessary. How can we be objective in review? You can say something like, this method is missing a docstring, instead of, you forgot to write a docstring. Review should be a learning opportunity and not just a chance to catch someone with their pants down. You want to ask questions instead of giving answers. You can say something like, would it make more sense if, or did you think about it this way? Offer suggestions. It might be easier to, or we tend to do it this way. It's always better to offer a suggestion than to give an ultimatum. Most importantly, avoid these terms. Simply, easily, just, obviously. They're obviously condescending. If it was so obvious, the submitter wouldn't have done it in the first place. They might just be missing context or unaware of a particular concept. Another big one to avoid is, well, actually. When someone says, well, actually, they're just interrupting you to make a minor correction. So if you're saying, well, actually, take a time out and pause and try to figure out exactly what you're saying. Now, I'm not sure if any of you practice yoga, but this happens in my yoga class absolutely all the time. The teacher, she'll twist herself into a pretzel, and then she'll tell the students to now simply touch your feet to your forehead. I don't think any of you would consider this simple. To be effective, you need to have clear feedback. Your opinions need to be strongly supported for maximum impact. You need to share how you would implement your suggestion, along with why you think the change is necessary. Try to link to blogs, documentation, or other resources that back up your opinions. And don't feign surprise if someone says they don't know something, even if you consider it a basic concept. Don't say, gasp, I can't believe that Dave doesn't know about the singleton design pattern. It's not helpful to anyone. This is not clear feedback. Remember to compliment good work and great ideas. I like to leave a big thumbs up when I see something like a good refactoring, really clean code, a particularly elegant solution. Reviews shouldn't be all about the bad. You don't want to be a perfectionist. Rebecca said it better than I can. She said, the goal is better code, not exactly the code that you would have written. So don't be a perfectionist. For big issues, you don't want to let perfect get in the way of something that's perfectly acceptable. So prioritize what's important to you, and know that usually for the big stuff, 90% there is good enough. When you press for complete perfectionism, what you're doing is you're taking ownership away from the person who wrote the code. You're taking away their feelings of creativity and accomplishment. So be especially careful of this one. But know that it's okay to nitpick the small stuff. Things like syntax issues, spelling errors, bad variable names, missing corner cases. You might ask, what's the harm in just letting a few of these through? Well, there's something known as the broken window theory. In regards to code, when I see sloppy code, I think it's okay to check in sloppy code too. So feel free to nitpick, but do it last. You want to make sure that you've already addressed the big stuff like architectural concerns and design decisions. As a reviewer, you want to avoid getting burned out. Studies show that you can look at about 200 to 400 lines of code at a time for maximum impact. And you want to do those reviews in about 60 to 90 minutes, then take a break. So in practice, reviewing between 200 and 400 lines of code over 60 to 90 minutes will let you find about 70 to 90% of the bugs. If 10 bugs existed in your code, a properly conducted review would find between 7 and 9 of them. Studies show, though, that after 500 lines of code, the ability to find bugs reduces dramatically. If the code stops making sense, you're tired, take a break. You might miss something. And a good rule of thumb is to do reviews within 24 to 48 hours after they've been submitted. This is especially easy when reviews are small. Remember, 500 lines of code. This lets you do the reviews incrementally and not create a huge backlog. And it also means that the code is fresh in the submitter's mind for questions. You don't want to end up like this guy who's still waiting for a code review. For good communication, you also need to define done. When you're finished, say if the review is complete or if you're still waiting for changes. Use consistent language. My personal favorite, ship it, or looks good to me. If the submitter needs to push code based on your comments, say changes requested. Make sure you follow up and actually check the code when the submitter says they pushed a fix. So, how do we be a great reviewer? We have empathy. We watch our language. We give really clear feedback. We give compliments for good work. And we're not going to be a perfectionist. Remember, we need to avoid burnout and take breaks. But don't leave your teammates hanging. Finish those reviews in 24 to 48 hours. And lastly, define done. Now, we spend a lot of time talking about how to be a great reviewer, but there's two sides to this coin. For effective reviews, we need to learn how to be a great submitter too. In this comic, the submitter is saying, oh, no need to double check this change list. If problems remain, I'm sure the reviewer will catch them. And the reviewer on the right-hand side is saying, oh, no need to look at this change list too closely. I'm sure the author knows what he's doing. This happens in great teams. So you want to avoid getting rubber stamped. What is rubber stamping? It's when the submitted solution is just so complex, the reviewer thinks it's absolutely obvious that the author knew what they were doing. And they just stamp, approve the code without fully understanding it. You don't want to be too clever, because submitting complicated code is just a surefire way of getting rubber stamped. I have a developer friend who used to love showing off how smart they were by checking in complex, over-engineered solutions. He stopped doing it when he realized he was punishing himself because it meant that he always ended up being the maintainer. Remember that readability counts. Russ Olson said it best. He said, good code is like a good joke. It needs no explanation. If you feel like a piece of code is confusing, it is. Right? Leave a comment either in your code or in your code review tool, but better yet, refactor it so that it's more readable. There's a few stages to review. Stage 0, because I'm a developer. You start before submission. Stage 1, your review is submitted. Stage 2 is optional. You can submit a work in progress at 30 to 50% done. At stage 3, you're almost done, so let's say 90 to 100% complete. At stage 4, the review is completed. At step 0, we need to think about what we want to do before we even submit the review. We need to provide the context, the why. This is the most important thing you can do to help your reviewer. Why did you write this code? Link to the underlying ticket or issue. If there's not enough context, provide more. For a larger pull request, you can even consider inserting a changelog. And remember to try to point out any side effects. Now that you provided the context, you need to remind yourself that you are the primary reviewer. So, review your code as if you were giving a review. This lets you anticipate problem areas. As the primary reviewer, it's our responsibility to make sure that our code works. It's thoroughly tested. We've QA'd our own changes because you don't want to rely on someone else to catch your mistakes. One way to be a better submitter is to try a checklist. What makes a good checklist? Well, we can check for the small stuff. Did you look for reusable code or utility methods? Did you remove all the debugger statements? Did you make sure that you have clear commit messages? You can also check for the big stuff. Is your code secure? Is it going to scale? I highly recommend a book called The Checklist Manifesto. It's a book about how checklists help doctors make surgery safer and how it helped pilots help deal with disaster. Checklists can certainly help developers too. Now we're at step 1. You've submitted the review. At this point, you're starting a conversation. Don't get too attached to your code before the review even starts. You want to anticipate that there will be comments and feedback and acknowledge that you're going to make mistakes. Remember, the whole point of a review is to find problems, and problems will be found, so don't get caught by surprise. The optional step 2 is submit a work in progress pull request. What's the benefit of this? It's really helpful for bigger and more complicated tasks. Rule of thumb, you want to submit them when you're about 30 to 50% done. Don't be afraid of showing incremental or incomplete work. This especially drives perfectionists crazy. But this stage is the right time to get feedback on those bigger issues. Because when the code is a work in progress, the kind of feedback that you should expect is architectural issues, design problems, maybe recommendations for design patterns. At this stage, you really want to be getting that feedback both early and often. When we're at the step 3, the almost done phase, we can actually see the finish line. What kind of feedback can we expect at this stage? Things like nitpicks, bad variable names, requests for documentation or additional comments, and things like small optimizations, because as the code evolves, it should become more firm. No one wants to hear the phrase, change it all, at this phase of the process. At this point, you also want to ask yourself, did I end up solving some unrelated problem? Did I only solve one issue with my pull request? If the answer is no, you want to break that code up into multiple reviews. If you branch that code off a feature branch, that'll also help you keep your diffs small. We want to keep our diffs small because we want to prevent reviewer burnout, because those reviews lose value when they're more than 500 lines of code. Keep them small and relevant, but if a review is big and that's just unavoidable, remember to give the reviewer a little bit of extra time. We can use automated tools and static analysis to streamline our review process. We can use something called a linter. What is code linting? It's an automated way of checking syntax, or if you want to get really fancy, you can set up your linter to check style guide violations too. This is an example of a Python linter. The linter can integrate with your code editor or IDE, and this way the reviewer is not wasting their time pointing out syntax problems. Tests? Write them? No, really, write tests? Because tests need to be passing for someone new to be able to meaningfully contribute. You don't know the status of your code health if your tests are failing. Writing tests will help you identify problems immediately. I'm not going to go into too much detail on this step because there are so many great talks and resources on testing. I can talk about it for hours and hours. If I haven't stressed the importance of tests enough, though, remember that no one wants to work with scumbag programmer who commits untested code. Don't let that be you. We can also use continuous integration. What is continuous integration? It's an automated build with every push. It'll run the compiler, run tests. This should be happening a few times a day. There are lots of tools available, Travis, Circle CI being some of them. Almost all of them integrate with GitHub pull requests. This is an example of part of a Travis report that shows up in your pull request. We can use coverage. What's coverage? It's the percent of code that's executed when a test suite is run. Now, remember we talked about fault tolerance. If you have low fault tolerance, for example, if your code fails will mean someone getting stuck in an MRI machine, then coverage is an absolutely necessary tool. A coverage report looks something like this. Coverage tools can also integrate into GitHub. For Python, there's coverage.py. There's also a product that works with lots of different languages called coveralls. Here's an example coveralls report integrated into GitHub. Automation will save us time almost every time. Now we're at the last step. The reviewer has finished looking at your code, but we're not done. Remember, we need to be responsive. If the reviewer has left comments, we need to reply to each and every one. Common responses to a comment are resolved or won't fix. If you won't fix, though, you need to explain why and make sure that you've come to an agreement. At this point, it's still a conversation. After the first pass, you need to let your reviewer know when the code is ready to be reviewed again. But don't bike shed. What's bike shedding? It's arguing over minor, marginal issues while the more serious ones are still being overlooked. For example, people argue about what color to paint the bike shed when the house is still not finished. If you're not familiar with this concept, I recommend checking out bikeshed.com. But as a rule of thumb, if you're going back and forth more than 3 times, it's time to step away from the keyboard and use your words instead. If you're co-located, that's awesome. Stop by and have a chat. If you're working with someone remotely, hop on a video call. But most importantly, record the conversation for posterity in the review. If you're disagreeing with the reviewer's comments, don't respond with radio silence. Carefully explain to the reviewer what they might have missed. Open a discussion and try to understand why the reviewer left that comment. Maybe the reviewer missed your thought process, but maybe you're just wrong. It happens sometimes, even to the best of us. So learn to admit defeat. Admitting that you don't know something is really hard, but don't take it personally. You are not your code. Use it as an opportunity for growth. And remember, we're all working towards the same goal. We want to ship code. Be grateful during the process and offer thanks that someone spent the time to review your code. So how do we be a great submitter? We provide the why. We review our own code first. We expect that conversation. We submit in-progress work when it's necessary. We use automated tools. We be responsive, but when necessary, we accept defeat. Now, I've shown you how code reviews build a stronger team. How can we use that as an advantage when someone new joins? Because it doesn't matter how much experience you have. On your first day, you probably feel something like this, right? I have no idea what I'm doing. So how do we help out the newbies? We need to remember that the new person that's joining our team might not have experience being reviewed. If you've never had anyone look at your code before, it's really easy to get scared and think, what are they all going to think of me? Remember your first review. You want to ease that new person into the process. So when you onboard, you can encourage that newbie to read recently completed code reviews before they submit their own. Remember that first review is going to be the absolute hardest one. The first few reviews should be small. Don't let someone stumble around in the dark on the wrong path without any guidance. Share that style guide that we talked about earlier so that expectations are set. But remember that expectations are good, but don't be too rigid. Evaluate new ideas or best practices that new person might bring from their old company. We talked about how everyone should be a reviewer. Now, how does that work with junior people? A study showed that familiarity with the code was an important factor in increasing the likelihood of useful comments in a review. So instead of muscling out those junior people, you can try to have them do a peer review with a more experienced developer until they're more familiar with the code base. You can use it as a mentorship opportunity. A coworker of mine said a quote that I think really sums it up. He said, "When your team succeeds, you succeed." Kind of cheesy, but I think I agree with it. A friend of mine, Sasha, said it best during a talk of hers on giving and getting technical help. She summed it up this way. She said that hiring senior engineers is hard. It's true. Instead, you can hire junior engineers and grow them into a functional and productive part of your team. Use their culture of review and knowledge sharing as a competitive advantage to make this process faster and easier. If you're not doing code reviews, you're missing a big opportunity because code reviews provably shown to improve code quality across all kinds of organizations and code bases. Think about what's blocking your team from trying some of the techniques I talked to you about today and figure out ways of eliminating those blockers. Remember that for a successful culture, you need to allocate the time for review. You need to let that culture grow organically. This is just not something that you can force. These ideas are not one size fits all. And code reviews are not a one-stop shop. They need to be used in addition to things like tests and QA and other methods for maximum impact. If reviews are not already in place in your organization, anticipate those stumbling blocks. But really, in no time at all, you're going to see a big payoff in less buggy and more maintainable code. What's the most important thing that we learned about code reviews today? We learned that, at a minimum, code reviews decrease the rate of WTFs per minute. And as we all know, that's the only valid measurement of code quality. We all want to be working with the team on the left. We want less WTFs per minute because less WTFs per minute mean happier developers. Now, before I leave you today, I wanted to let you know that there's bonus material at the end of my slides. The slides are located at bit.ly/reviewcode, all lowercase, all one word. Thank you so much for your time.